There we go. Okay, so let's start with this first question that I have here. And the first thing that I notice here is that we have an allylic lone pair. So let's start by moving that allylic lone pair and making a new pi bond. So we're going to take that and we're going to make a pi bond between the carbon and the nitrogen. But that would give this carbon too many bonds. And so we're going to move this pi bond over here and put the lone pair on this carbon. And that will give us a structure that looks something like this. Make sure you draw your 6-membered ring very carefully. Make sure you draw this 5-membered ring. So 1, 2, 3, 4, 5 atoms very carefully. Now we have the negative charge on this carbon. We have another allylic lone pair. So we can draw the delocalization of those electrons to make a new pi bond here and put the pair of electrons on this carbon on the bottom. We draw a resonance arrow, draw our 6-membered ring, which now has these 2 pi bonds and the lone pair down here. And that, of course, will be where our negative charge has been delocalized to. And then there's one more resonance contributor that we can draw, and because we have another allylic lone pair, so we can move the electrons up here, and I'll draw that guy right here, and that is going to look like this. So we have something that looks like that, and that would be our final resonance contributor. Could you draw one more resonance contributor? Yes, for sure. Yeah, I'm missing the positive charge on my nitrogen, aren't I? So I should have one here, here, and here. Yeah, so I could draw one more resonance contributor where I do this, okay, but that's going to take me right back to where I started. All right, so there we go. We have all of the resonance contributors drawn for this molecule. So let's move on and let's try 2.52F. Remember that we don't want to try to create new charges, but we have an allylic carbocation right here. So let's start by drawing the pattern that we saw for an allylic carbocation. We're going to move the pi electrons over here, and that will give us a new resonance contributor, which is going to look like this. So we end up with this here. And now we have, oops, am I missing? Yeah, there we go. I added a carbon. There we go. That's more like it. So we end up with something that looks like this. And now you can see that we have another allylic carbocation right here, just like this. So we can push the pi electrons over here and make a new resonance contributor. It's going to look like this. We have the double bond here. The positive charge is moved. And then like this. And then we have another allylic carbocation like this. So let's keep going. Don't stop until you've drawn all the possible resonance contributors that you can come up with. We're going to move that pair of electrons from the pi bond down here, and we end up with positive charge here, double bond here, double bond, and this, like that. And now we can draw one more resonance contributor because we have a carbocation next to a lone pair. And let's do that. So we're going to take the pair of electrons from the lone pair, put them in here, and we'll end up with our last resonance contributor. We'll have a double bond here, like this. Then we'll have a double bond, single, double bond, like that. And now the positive charge is on my oxygen. There we go. Nothing to it. So we've drawn all the resonance contributors there. And let's try one more. This is question 2.61. So with question 2.61, what we're going to do is we're going to start with our allylic lone pair up here. Let's start with that, and we'll start by drawing the same 2 curved arrows. We make our pi bond, break this pi bond, put a pair of electrons here, and let's redraw the structure. So I might copy and paste this to make it a little faster. So we end up with this. Let's see here, copy, paste. All right, so let's draw what we ended up with from here. We've got a double bond here. So now we've got a positive and negative charge. We've got a double bond here, 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 and here. So now we can show the delocalization of that negative charge because we have an allylic lone pair right here. So we're going to draw formation of this pi bond, and then we're going to show these pi electrons coming down here, which is going to give us the carbanion over here. Now we have a double bond here and here. Here's our positive charge. We have a double bond here and here as well. Okay, let's put in another contributor. So now we have another allylic lone pair. And we're going to make a new pi bond here and put a pair of electrons over here, which is going to give us something that looks like this. So we have this, we have the double bond here, the lone pair here with our negative charge, double bond here and here. We have another allylic lone pair. We're getting my resonance arrows, so let's put those in. Let's keep going. This here. We're going to need another one, aren't we? There we go. So let's put this over here. Okay. So now we've still got our double bond here with our positive charge. We haven't touched this or this. We're going to make a new pi bond and move this pair of electrons over here. And so we have our pi bond here, lone pair here, double bond here. And then we have another allylic lone pair, and this is the last one, thank goodness. And so same old pattern. We take our pair of electrons, we make a double bond, we move this pair of electrons onto the next carbon, and there we have it. That would be our last resonance contributor. So let's put everything back together like this, and then we have our lone pair over here, and our negative charge. And those are all the resonance contributors we can draw in question 2.61. And so again, it's the kind of thing you could watch me draw resonance contributors for the next 6 hours, but unless you give it a shot with a pencil and a piece of scratch paper, it is very difficult to master. I would say impossible to master the concept of resonance structures. So be sure to try all the practice problems from chapter 2. And if you have any questions, don't hesitate to contact me by email, and I will get back to you as soon as possible.